Alright, Unit 19, Day 6. These are the notes for linear, quadratic, and exponential models. So, basically when we say models, we're basically saying what these graphs essentially look like. Alright, so every one of these graphs has a very basic form, a very basic look to it. Linear graphs are going to kind of look like that. Quadratics are going to kind of look like that. And exponentials are going to kind of go like that. Or, like that. So basically what we're doing is we're basically trying to put a face to these names. Mathematically speaking. So the first thing that we're going to do is we're going to talk real briefly about these tables. Alright, now in a linear function, we know that there's going to be the same common first difference. So if you'll notice, from negative 10 to negative 5, that's plus 5. From there to there, it's plus 5. There to there, plus 5. And so on and so forth. Alright, and that's the first difference. Okay? That's the first difference. All right, and the parent function for all linear functions is going to be y equals x. All right, don't forget that. That one's important. Okay, now with quadratics, they have a common second difference. So what we do is we take the first difference on each of these. So that's going to be 1, 3, 5, 7, and 9. And if you take that first difference and you realize, ooh, well, there's nothing in common there, well, then you can take the second difference, and that's 2, 2, 2, 2. So basically, you find the jumps in between the jumps. So that's a good way to look at those. And the parent function for all quadratic functions is y equals x squared. All right? Now, let's see. For exponentials, you're going to have a common multiple. All right, so if the first difference test and the second difference test don't work, then you go through and you look at the multiple tests. So the jump from 1 to 2 via multiplication is going to be 2. Jump from 2 to 4 is by 2. And then 4 to 8, we multiply by 2. From 8 to 16, we multiply by 2. And from 16 to 32, again, we multiply by 2. Alright? Not too bad, okay? And then, of course, we have a graph of the parent function for each of those. And the thing is, as you'll notice, it says parent graph, parent function. There's no parent function written there. That's because there's too many things to kind of go into these. So there is no parent function to the exponential. And that's just kind of the way it is, but yeah. Anyway, moving along here. The first, number 1, what we're going to be doing is we're trying to determine if the following equations represent a linear, quadratic, or exponential function. Alright, linear, no exponent. Okay, with quadratics, you're going to have a squared term. Okay, exponentials, you're going to have x as the exponent. Okay. Alright, so number 1. Okay, we got an x as the exponent. That means it's exponential. Alright. Number 2. Okay, no exponent. That means that it has to be linear. Alright, number 3. There's a exponent of 2. That means that it's quadratic. Alright. Now, number 4 is a trick question, okay? Thing is, after you do your FOIL on that one, you wind up with x squared plus 2x minus 8, which, as we all know, that's a quadratic. Alright, that's a quadratic. Number 5 is exponential. Okay, and number 6, if we minus 2x from both sides here, we get y equals negative 2x plus 7. As you can see, there's no exponent, so this is linear. Voila, it's that easy. Okay, today's a very easy day. Alright, the second little section, it asks us to determine if the following tables represent a linear, quadratic, or exponential function. Alright, for the first go round here, okay, we notice plus 3, plus 1, minus 1, minus 3. So if we notice, we're minusing 2 each time. Therefore, on the second difference, we got a common second difference, it's a quadratic. Okay? Right here, okay, if we notice, our jump from 1 to 3 is plus 2. Alright, our jump from 3 to 9 is plus 6. Oop, not good there. And then if we go from 2 to 6, that's 4. This doesn't look like it's going to be a second difference either. Alright, so we're going to try multiplying by 3. 3 times 3 is 9. 9 times 3 times 3. Ah, hey, we got a common multiple, so that means that it's exponential. Alright, on number 9, we're going to go, let's see, plus 2, plus 2, plus 2, and plus 2. And that's linear. Alright, on number 10, okay, if you notice, we're going to divide by 2, divide by 2, divide by 2, and divide by 2. So therefore, this is an exponential. Okay. Next thing, okay, it says to graph each data set, determine if the following points represent a linear or quadratic or exponential function. Alright, so negative 2 up 8, so negative 2, 8, negative 1, 4, 0, 2, 1, 1, 2, 1 half. Alright, and if you notice, the graph kind of goes like that, and this is exponential. Alright, next one, we got over 0 up 3, over 1 up 9, over 2 up 11, over 3 up 9, over 4 up 3. Alright, and as I see it, I kind of go like that, and that's a quad. Alright, so there it is. Alright, let's see. Oh, hey, there's a space underneath it. Exponential and quadratic. Alright. Alright, now it's time for some more of the same. So, let's see, we got over 2 down 7. Negative 2 down 9. Over 0 down 8. Over 4 down 6. Over 6 down 5. Alright, so let's see. That line doesn't look half bad. Alright, so this, of course, is linear. Alright, now number 14. Okay, we go negative 3 up 9. Negative 2 up 4. Negative 1 up 1. 0, 0. Over 1 up 1. Over 2 up 4. And, of course, that point would be there too, up there at 3, 9. So, this is a quadratic. Alright? And not only is it a quadratic, it's the quadratic parent function, which is really kind of cool. Alright? Let's see if I can get that line back up. Alright. Alright, so it says that the height of a plant at weekly intervals over the last 6 weeks was 1 inch, 1.5 inches, 2 inches, 3 inches, 3.5 inches. 1, 1.5, 2. Missed one. Oopsie. 2.5, 3, 3.5. Alright, so this is 6 weeks, so 6, 5, 4, 3, 2, and 1. So over 1, up 1. Over 2, up 1.5. Over 3, up 2. Over 4, up 2.5. Over 5, up 3. And over 6, up 3.5. Okay, you'd have to be pretty much blind to not be able to see what kind of function this is. Okay, this is a linear graph. Okay, make sure that y'all go ahead and plot those points and just see. Your visual acuity is very important to this particular day. Alright, so all it says is matching. This one took me a second to realize that there's this huge bank down here of linear, quadratic, and exponential stuff. So I'll be hopping between the bottom of the page and the top of the page for a second. So these equations, okay, now as we know, A has this little x as the exponent. So that means that this is going to be exponential. Alright, B is going to be linear. And C is going to be quadratic in nature. Alright, so that means A is going to go under exponential. A is exponential. C was quadratic. And B was linear. Alright, now for our graphs, okay, of course this distinct U-shaped curve is going to be a quadratic. This really sharp upturn is going to be exponential. And of course, if it's a line, it's linear, or linear, whatever you want to say, linear. Okay, so let's see, we got D is quadratic. We've got E is exponential. And F is linear. Alright, now that's the last little bit here, these tables. Now, as we remember, okay, we're going to look at the jumps. Plus 1, plus 1, plus 1, plus 1. That means that this must be linear. So the table has to be, or table G is linear. Table H, okay, let's see, we got plus 6, plus 2, minus 2, minus 6. My jumps between that are minus 4, minus 4, minus 4. So that means that H is the quadratic table. And let's see. See, my jump from 0.25 to 0.5 is times 2. And I'd multiply 0.5 by 2 to get 1 times 2 times 2. So that means that the table J is exponential. And that is the end of the notes. Like I said, real easy day, y'all.